Hello and welcome. Do you want to learn PLC wiring in a simple and easy to understand way? If you're a beginner, this video is made just for you. The PLC we are using belongs to the Delta DVP family, which includes several models that differ in inputs-outputs, communication options, and processing speed. For this video, we'll work with the DVP-14SS2, a compact PLC with built-in inputs and outputs, making it ideal for small projects. First, I'll explain all the parts of this PLC, and then we'll move on to step-by-step wiring. In the next video, we'll use this setup to program the PLC and run our project. The DVP-14SS2 PLC has 8 digital inputs and 6 digital outputs. If your project needs more inputs and outputs, you can easily expand the system by adding additional digital or analog modules. Here are the input terminals. These are used to connect sensors, switches, or push buttons. Each input is labeled with the letter X, from X0 to X7. In programming, we use these addresses to identify which input is connected to which device. In front of the input terminals, there are 8 indicator LEDs. When an input is activated, its corresponding LED lights up in red, making it easy to see which input is currently active. At the bottom, you'll see the output terminals. These are used to connect output devices such as relays or contactors. The DVP-14SS2 PLC comes with 6 built-in digital outputs. In Delta PLCs, outputs are labeled with the letter Y. So on this model, the outputs range from Y0 to Y5. PLC outputs can be either relay or transistor type. If you see the letter R in this section, it means the output is a relay output. And if you see T, it indicates a transistor output. In this video, we will explain how to wire both relay and transistor outputs. On some output terminals, you may notice labels with the letter C. These are common terminals and are only used with relay outputs. The DVP-14SS2 PLC has 3 common terminals, C0, C1, and C2. C0 is the common terminal for Y0. C1 is the common terminal for Y1. C2 is the common terminal for the remaining outputs Y2 to Y5. For example, if the PLC sends a command to turn on Y0, the C0 terminal connects to the Y0 terminal. In front of the output terminals, you'll notice LEDs that indicate the status of each output. When an output is turned on, its corresponding LED lights up, showing that the output is currently active. These LEDs on both inputs and outputs are very important and play a crucial role in system diagnostics. For example, imagine you wrote a program where activating the first input should turn on the Y0 output. If the system doesn't behave as expected, you can use the LEDs to troubleshoot. First, check the input LED. If you press the first input and the LED does not light up, the problem might be with the push button or the input itself. If the input LED works but the output LED does not turn on, the issue could be with the output device or the wiring. By observing these LEDs, you can quickly identify whether the problem lies in the input or output side, making troubleshooting much faster and easier. When using a Delta DVP PLC, there are 3 main status LEDs on the front panel: power LED, lights green when the PLC is powered on correctly. Run LED turns on when a program is loaded, and the mode switch is set to run, meaning the PLC is executing the program. Error LED indicates faults or abnormal conditions. This terminal provides an RS-232 communication port, which is used to connect the PLC to other devices, such as an HMI, or to upload and download programs to the PLC. To use it, one end of the RS-232 cable connects to this port on the PLC, and the other end connects to the RS-232 port on your PC or laptop. At the bottom of the PLC, you will find the terminals for connecting the PLC to the power supply, and the RS-485 communication port. The RS-485 port allows you to easily connect the PLC to devices using the Modbus protocol, making communication with other controllers, HMIs, or sensors straightforward. Now we want to learn how to wire the DVP PLC. For the wiring part of this lesson, I'll start with the DVP-14SS2 model with relay outputs. After we finish the relay wiring, we'll move on to the transistor output version and compare the differences. DVP-14SS2 model with relay outputs. In this project, we have two push buttons, one for start and one for stop, plus a relay and a contactor. In the next video, we'll write the program and download it to the PLC. The logic will be simple. When I press the start button, the PLC activates its output. The relay energizes. The contactor pulls in, and the motor starts running. When I press the stop button, the PLC deactivates the output. The relay releases, the contactor drops out, and the motor stops. To keep the wiring clear and avoid unnecessary complexity, first I remove the power circuit from this demonstration and keep only the contactor in the diagram. First, let's start with the input wiring. I will connect the SS terminal to the 0 volt of the DC power supply. With this configuration, the inputs operate in source mode. That means whenever you connect 24 volt DC to any input terminal from X0 to X7, the corresponding input will turn on and the PLC will detect the signal. Next, I connect the 24 volt DC from the power supply to the input side of both the start and stop push buttons. From the output of the start button, I run a wire to the PLC's first input terminal, X0. Then, from the output of the stop button, I connect a wire to the next PLC input, X1. By the way, for the start button, I'm using a normally open contact because we only want the signal when the button is pressed. For the stop button, you can use either a normally open or normally closed contact. It depends on your design preference and how you want the control circuit to behave. For motor protection, I'm using a thermal overload relay installed downstream of the contactor. I connect the relay's auxiliary contact to one of the PLC inputs so that, whenever an overload occurs, the PLC can detect the fault and respond accordingly. First, I connect terminal 95 to the 24 volt DC supply. And then I route its output to terminal X2. Now let's move on to the outputs. This PLC has relay outputs, which can be used with either DC or AC loads. You could connect the PLC outputs directly to the contactor coil, but for safety, I use an intermediate relay between the PLC output and the contactor. This approach protects the PLC. If the contactor coil develops a fault or a short circuit, the PLC outputs remain safe because the intermediate relay absorbs the overload. Using a relay in this way ensures both safety and reliability in the control system. I connect the first COM terminal C0 of the PLC to the 24V DC power supply. Then connect the Y0 output, the first PLC output, to the A1 terminal of the intermediate relay. Finally, I connect the A2 terminal of the relay to the 0 volt of the DC power supply. Now, I connect the phase of the AC power supply to the COM terminal of the relay. From the relay's normally open contact, I connect to the A1 terminal of the contactor. Finally, I connect the A2 terminal of the contactor to the neutral of the AC source. This completes the AC side of the circuit, ensuring that when the relay is energized by the PLC, it safely powers the contactor, which in turn starts the motor. We've finished this wiring setup. Now, I will remove the intermediate relay and connect the PLC output directly to the contactor. I want to show you how it works in this configuration. I connect the first common terminal C0 of the PLC to the phase of the AC power supply. Then, I connect the first output Y0 to the A1 terminal of the contactor coil. Finally, I connect the A2 terminal of the contactor to the neutral of the AC power supply. This setup allows the PLC to control the contactor directly, turning the motor on and off without using an intermediate relay. Now, let's move on to transistor outputs. Unlike relay outputs, transistor outputs are solid state, which makes them faster and more suitable for low-current DC loads. In this section, I will show you how to wire the PLC with transistor outputs safely and correctly. The input wiring for a PLC with transistor outputs is the same as with a relay PLC, so I won't repeat it. Instead, let's move directly to the output wiring. As you can see, transistor outputs don't have a common terminal like relay outputs. Instead, you'll see up and ZP terminals, which are used to power the output transistors. Delta PLC transistor outputs are NPN type, so you connect the positive side of the power supply directly to the load, and then connect the negative side of the load to the PLC output. It's important to note that AC loads cannot be connected directly to transistor outputs. For AC loads, you need to use an intermediate relay to safely control the device. I connect the positive terminal of the power supply to the up terminal, and the negative terminal to the ZP terminal of the transistor outputs. Next, I connect the A1 terminal of the intermediate relay to the positive side of the power supply, and the A2 terminal to the Y0 output of the PLC, the first output. On the AC side, I connect the phase of the AC power supply to the COM terminal of the relay, and then connect the relay's normally open NO contact to the A1 terminal of the contactor coil. Finally, I connect the A2 terminal of the contactor coil to the neutral of the AC source. With this, the wiring is complete, and the system is ready to operate. With this, we have completed the wiring setup. If you want to see this wiring on real hardware, let me know in the comments. I will record it with the actual PLC and upload it for you. In the next video, we will move on to the real hardware, perform the practical project together, and start programming the PLC so the motor can be controlled using our buttons and protection devices. Thank you for watching, and don't forget to like, subscribe, and comment if you want more practical PLC tutorials.